Thank you very much. Good morning, everybody. It's my great pleasure this morning to introduce Dr. Gavin Schmidt. Dr. Gavin Schmidt is a senior scientist and also the director at the Goddard Institute for Space Studies in New York. And he's done an enormous amount of research over the years looking at the causes of climate change. But actually, you're not going to hear about that too much this morning. It's more about his other passion, and that's on the communication of climate science. And he's a fantastic communicator, as you'll see very shortly. But I also noticed that as he's also a director, he has to deal with a lot of urgent matters, and he's been on his mobile phone this morning, but I'm sure he's going to overcome that and give us a great performance. Thanks very much, Gavin.
Thank you very much. See, the thing about being on the last thing on a Friday is everyone's gone home already. But for the people that remain, I'm going to talk a little bit about climate change communication, what works, what has not worked, and perhaps how we can do a little bit better. And then perhaps in the question and answers, I can talk about why none of this is actually going to make much difference to anything. So there's some great climate communication efforts out there in the web. This is Kate Marvel gave a TED talk in 2017, which has been seen by 1 million people. You know, that's quite impressive. It was a good talk about clouds and climate sensitivity. Many of you might have seen this at the opening ceremony of the Olympics last year. And it's a temperature spiral. It's a visualization of the temperature data that was made by Ed Hawkins, and even putting the opening ceremony of the Olympics aside, it's been seen many millions of times. So you know that's good communication, right? This was another data visualization, which I won't go through, but you can find it if you want, on the attribution of climate change that was put together by Bloomberg Media with help from NASA GIS, including myself, and this was their most viewed data visualization for the whole year, and they won't actually tell me how many people viewed it, but it is in the many millions. So you know. That was good. Some of you might remember this. This was a video that was put together that was supposed to be funny to support a campaign to reduce emissions by 10% in 2010. But unfortunately, it used the imagery of exploding school children if they didn't agree with the need to cut emissions. So as you might expect, that did not go over very well. The campaign was launched and then unlaunched pretty much within half an hour when people started complaining about what was going on. And the issue here is the people that we're trying to get to come on board feel that they're already being victimized. And then when they're kind of explicitly victimized by being blown up, that tends to rub a little raw. So that was a total disaster in terms of a climate communication. And the video has had 500,000 views since, which is small compared to the good stuff, but it's noticeable compared to the stuff that's not so great. But let's be clear. It's very hard to move the dial on big public conversations, and the efforts of individuals or institutions, it's hard. So, for instance, this is a Google search trends. The red line is searching for global warming. The yellow line is searching for climate change. And you can see that global warming has become a little bit less popular over time. Climate change has become a little bit more popular. And there's a couple of big blips here. So that big blip there was March 2007. That was basically the reporting of the IPCC AR4. That actually got a lot of publicity. People are already throwing cans at me. What's going on? Sorry. And that actually got a lot of media. It got a lot of attention, possibly because people who hadn't been paying attention suddenly started to pay attention. This was November 2010, so some of you might remember the ClimateGate affair, but you can see that that was a very short-lived issue in terms of Google, right? A lot of people Googled it right at the time, but as you can see, nobody Googles it anymore. Now, unfortunately, September 2013 was the launch of the AR5 IPCC report. Can you see September 2013 in that graph? You cannot. So it's hard, and IPCC is a big deal. So that's the background. Now let's look at what actually a lot of people see.
All our grid models are worthless.
I don't think grid models are going to be a lot of help here.
They are not, indeed. They are not going to be any help. So the day after tomorrow, the movie that was so bad it actually prompted me to start blogging has been seen by hundreds of millions of people. Worldwide gross is almost $500 million, and was seen by far more people than anything that anybody has ever done. For comparison, the documentary by Al Gore was seen by about 1/10 as many people. Effective communication is hard. It is, and it's not something that we're innately good at or not innately good at. It is a craft, and it is something that one can work on. And you do get better at it with time. Some of the problems that we have is when we have early career researchers who have a big paper that comes out, and their first time out is also their biggest splash ever, and that's not the greatest place to learn how to do this well. Luckily, a lot of the youth in our community now are starting to do small-scale communication at a very early stage with Twitter and Facebook and other social media. And so we are, I think, enculturating a new generation of communicators who are starting small and who are getting better over time, hopefully before they have their big splash in the media. Okay. But why is this so hard? Why is this tricky? Well, it's tricky because our science has become politicized. What does that mean? Science gets politicized when the results of our scientific inquiry, what we're saying, appears to threaten things that are far more deeply held. Now, that could be vested political interests, vested economic interests, it could be ethical issues, it could be religious issues. And climate change is not the only science that has this problem. When this occurs, though, there is a kind of shadow debate, a shadow discourse that exists in the public that's very different to the discourse that happens at scientific meetings. New results that we produce, that we think of as being interesting, generally only appear in the public discourse to the extent that they project onto what this kind of shadow public debate is all about. And there's a flip side to this. The politics associated with this, because this is now a political issue, people love science, and they love using the mantle of science, the credibility of science, to argue for policy and to argue for their particular point of view. That leads to the situation where you have talking heads who are both politicians or commentators quoting science, quoting scientific results as if they knew anything about the process, and they don't. It's just a cover for an underlying argument that's much more deep. Obviously, that has nothing to do with the real scientific debate, and if you've ever seen, one of those talking heads situations, then you would know that very clearly. And the science is used to make a truth, as a lawyer might make a case. It's not there as an exploration of what's actually happening in the world. And so you get cherry picking of results, you get straw man arguments, you get red herrings, you get a whole gamut of logical fallacies that pop up whenever these things happen. And as I'm sure you do, looking at it, it's intensely frustrating to see the things that you know well totally mangled by people who are using it and abusing it. Nonetheless, there are some good consequences for having your science be a matter of public interest. Right? Scientific papers that do project onto this perceived debate, the attribution argument, the hiatus argument, the, is it going to be worse or better than we thought discussion. These papers are actually easier to get into Nature and Science and other high-profile venues. Now, the editors will tell you, no, we don't publish things because they're controversial. But one of the key things that they use to judge whether a paper should appear in Science or Nature is whether it will be of general public interest. The general public interest in our field is about things that are not very sensible. Therefore, if you have a paper that's not very sensible, it's easier to get into Nature and Science. Oops. There is a lot more media coverage and interest in your work, and that's great. You want to be doing things that other people care about, so that's nice. And if you, as a person or as a scientist or somebody who has a backstory that's kind of interesting or that fits some kind of niche or perhaps a stereotype, it can be great for your career. You get a lot of invitations to do interesting things. You get to testify in Congress. You can write op-eds, and people want to invite you places, and marvelous things can happen. But of course, there are some bad consequences as well. The work that you so carefully put together and put out is misquoted and garbled and totally distorted and made a total pig's breakfast out of. And it turns out that politics is not as nice as science. Who knew? Science is not always very nice. We've all heard about issues in science where people have abused their graduate students or there's been a hostile work environment. So it's not like scientists are some paragon of niceness that can't be questioned. But the fact is, if we disagree with somebody who's giving a talk here, the worst it will get is somebody will stand up and say, "Well, you haven't quoted my paper." The best riposte to that I ever saw was somebody stood up and said that, and the guy on the stage said, "Well, I knew you'd be here and you would do it for me." Scientists themselves become objects of public scrutiny because the best argument and the most effective argument to have somebody's view dismissed is to tell people that they are an imperfect human being. The shoot the messenger strategy is tried, tested, and very, very effective. And so when you stick your head above the parapet and your work is the subject of some controversy, you will find that the first reaction will be for people to criticize you personally. And that can be very raw and very unpleasant. The media reports that you so carefully contributed to generally end up not being very good. Right? There's a lot of false balance, there's a lot of sensationalism, and there's a lot of over-interpretation of your result. You've got something that reduces the error bars by 5%, and the headlines in the Australian are "worst case scenarios disproved," as we've seen very recently. And unfortunately, public understanding tends to decrease because they're actually being given just noise, and when people hear noise, they tune out the signal that they really should be hearing. And of course, constant debate about irrelevancies drowns out serious debate. And of course, that is part of a strategy. It's a media strategy to avoid having to deal with the bigger issues. So perhaps some of you saw this in the New York Times in August. No. Breathe easier. Pollution is not a problem. I should mention it was August 1971. And I bring this up for two reasons. One, the kind of counter narrative that everything is fine and nothing ever needs to be worried about in terms of the environment goes back decades. You read this op-ed, it could have been written yesterday. Just change a couple of things. There was one line in it which, so this is 1971, so it's kind of before people really started to think about the greenhouse effect. And there's a quote in there after he's gone on some little rampage about how pollution isn't as bad as he thought. He says, then there is the greenhouse effect. The buildup of carbon dioxide in the atmosphere, so goes this particular idiocy, will cause a temperature increase throughout the planet. What a ridiculous notion. And the second reason I bring this up is because of this guy here. So the guy on the on that side is Steve. I worked out up and down a long time ago. I really don't need to think about up and down, but like left and right has always escaped me. So the other left, perhaps. Anyway, so that's Steve Schneider, who died in 2010, but was a stalwart communicator of science since the 1970s. And he's standing with Jim Hansen, who was my ex-boss and whose job I now have. And he was at GIS at this time. And he wrote a letter to the editor, right? He got on his, this shall not stand. I'm going to write a letter to the editor. The opinion that we are winning the war against pollution that in the August 28 op-ed is based upon conclusions that are often inaccurate and certainly misleading. Again, a letter that could have been written yesterday. And that was his first letter to the editor. I think his first kind of public outreach that he did. And he was credited as being an atmospheric scientist at NASA GIS, which is the lab that I now run. The guy that actually ran NASA at that time was Robert Jastrow, who's an interesting character. But one of his traits was that he hated other people stealing the limelight. And so Steve Schneider had not asked permission to write this letter, and so Jastrow said, no, you're fired. He just fired him straight away. And it took a lot of finagling for him to get rehired, but I think Steve learnt a good lesson there and left to go to NCAR, where he spent the rest of his career the next year. Thankfully, people don't get fired for writing letters to the editor anymore, right? The thing that was interesting about this letter is that throughout that letter, there is only one line in it that could be described as a normative statement. And it's the last line. What we need to have is an accelerated program of scientific research along with improved international cooperation. That, my friends, is advocacy. So we're going to have a little pop quiz. Okay, you ready? So I'm going to put out a number of statements, and you're going to stick your hand up if you would be happy saying that to a member of the public. Okay? Okay, scientists should communicate more about what they do and find. Do you agree with that? Okay, pretty much universal. We need an accelerated program for scientific research and improved international cooperation. Yes. Yes, well done, people, yes. People should understand the basics of the greenhouse effect. Yes, good. Again, almost unanimous. Global warming should be in the high school curriculum. Yes, you guys, is there groupthink going on here? There should be a price on carbon emissions. Almost unanimous, not quite. The only solution to global warming is nuclear power. Really? Nobody? All right. Geoengineering should be seriously considered. Okay, that's good. So, what is the connection between all those statements? Yes, they're all normative statements. They tell us what we should do, not what is. Are they scientific statements? They are not. Okay, so we've already established that we're totally happy advocating, and that in fact we are all advocates for different things. So let's be clear about this. Science tells us what is, values our personal decisions about what we think is good and bad, tell us what ought to be. Advocacy is mingling of those two things. What we should be doing is a mix of our understanding about what is and what could be, combined with our values about what we want to see, right? Advocacy is inherently subjective. It is inherently value-based. There is no advocacy position that arises purely from scientific facts. Okay? And sometimes we forget that, and we should not. Scientists who communicate in public cannot avoid advocacy. You cannot be a scientist who wants to have a statement, who wants to have their views heard in public, and not be an advocate. And you might disagree with that, but why are you doing this? What are you hoping to achieve? Maybe you just want your name in the papers. That's advocacy for yourself. Maybe you want to change the world. That's obviously advocacy. You are doing it for a reason. If you're doing it for a reason, then it's a normative statement what you're doing. Even if you say, I'm only going to talk about the facts, why are you talking, and why are you talking about those facts here, right now, and in this location? We sometimes forget that, but the people who we're talking to do not. And so if you say, oh, I'm not an advocate, I'm not one of those terrible advocate people, people will say, they will see right through you, and they will say, no, you're an advocate. And so even if you do not explicitly seek the title, you will be branded with that A right there. So you have to define it yourself. You have to be very, very clear what it is that you are advocating for. And it doesn't have to be the same as everybody else. You could be advocating for an educational program. You could be advocating for research funding. You could be advocating to change the world. But be clear what you are doing. Because if you are explicit about the values that underlie your advocacy position, then people will address your values and stop a little bit arguing about the details that are not relevant. So you are going to be happier defining your advocacy position yourself rather than having somebody define it for you. But advocacy comes with risks, there's no question, right? Some of those risks are small and some of those risks are quite large. And it depends totally on the audience that you're talking to and the topic that you want to be advocating for. So let me give you a couple of examples. If I advocate for scientific literacy, we saw here basically that there was a unanimous thing, everybody's for scientific literacy, because we have a shared value that literacy is good. And in fact, that's quite widely shared. We can go outside and we can talk to members of the public, and they will also mostly agree that scientific literacy is a good thing. And so if I advocate for scientific literacy, I don't run any risks, because that's based on a value that's very widely shared. If I advocate for increased research funding, here it would be uncontroversial. But of course, in the real world, increased funding for science is decreased funding for something else. And maybe somebody cares about something else a little bit more than they care about research funding. And so outside our nice little community here, where we have shared values and we think that research funding is a good thing, it's more risky outside than it is here. If I advocate for a specific policy, we might not agree even in this room, and we might not agree outside. So that's not necessarily a shared value, and that has risks both professionally and publicly. Silence. It's odd, but silence is also an advocacy position, because when there are things that are wrong that offend your values and that you do not say anything, you in fact encourage those things to continue. So professionally, silence can in fact be quite risky. You know, if you are part of a situation where you see values being violated and you don't say something, and then later on the people find out that you didn't say something, that can be very harmful in a professional context. But of course, if you're silent, the public doesn't know who you are, and so there's no risk to your public persona. Let me just get that one. So what do we do? The first thing is do no harm. Do not allow your press affairs officer to write your press release for you. Number one. Distinguish your personal opinions from what everybody else generally believes. And that's hard, because we think, obviously, that what we think is what everybody should think. But be very explicit about that. Because every time you criticize other work in a very kind of general way, because you don't want to name names perhaps, that just gets translated as being a criticism of everything. And then you'll be the poster child for dissing the entire field of your colleagues. Be very clear about distinguishing between new ideas and things that are accepted. Even though all of those ideas are totally new to the audience, there's a big difference between like an idea that I've just had right now and something that's been part of the literature for decades. It really helps to provide context to your papers and to your work outside the technical literature. Write blogs, make videos, do YouTube interviews, and all of those other things. That really, really helps. There are a lot of pseudo debates that aren't real, that are just nonsense, but don't ignore them. Right? Sometimes there's a grain of something in there, and you don't want that to be the dominant narrative about what you're doing. Listen to people. I don't know why this is so controversial sometimes, but the best thing to do in communication is to stop talking and listen. And often, if you listen first before you try and communicate, that can be helpful. So, what works? Talk about the scientific process, how we come to our conclusions, how we sift through the evidence, how we look for fingerprints and all the rest of it. Talk about the process. Don't talk about results, because results just go over people's heads very, very quickly. You build on sources of credibility and trust, and you try and add to that credibility and that trustworthiness. It's much more important that you be seen and that you are a credible and trustworthy source than anything that you specifically say. Graphs are really, really hard. Words are hard, and obviously I've got a slide here that's full of words, and I'm feeling very bad about that right now. The imagery, animations really make a big difference. I'll give you some examples in a second. Lead with what you know. Don't kind of start off, well, you know, it's also uncertain, I don't really understand. And you get, well, and, you know, but we've come up to this conclusion that the attribution of climate change is actually 100% due to us. Oh, no, but plus or minus 10%, I don't know. It's totally irrelevant. Make your values explicit. Why are you doing this? Why are you on TV? Why are you writing a book? And prepare for what the reactions are going to be. Right? You're not putting information out into a void where nothing has been said before. Pay attention to what people say in op-eds and columns and all the rest of it right now, and know that when you put something in there, it's in that context. Okay, so people don't understand anything, right? You know, what's a model? Nobody has any idea what a model is. This is a model. Does that help? Does that help people understand anything? No. Thankfully, we no longer use punch cards. You'll be happy to know. This is a model. People love this. You dive into an animation like that, you go, oh, what's going on? Oh, look, the swirliness. It's orange and green and red. Isn't that pretty? You can tell a million stories with an animation like this, and people will be fascinated. Graphs like this, very useful in an audience like this, though I have to say there's been a number of cases where people have put 20 different graphs of this complexity on the same slide and with a whole bunch of text, and quite frankly, nobody can understand anything you're saying there. So that's just a tip. Anyway, there's a huge amount of information there. Oh my God, there's all the ups and downs, there's volcanoes, there's El Nino, there's the trends, there's, you know, what happened in the 1940s, and oh, look, the uncertainty. Okay, this is a technical graph, and if you use this in a public presentation, you have to really work through this. This takes about half an hour for people to get even like the first basic thing out of it. Okay, don't use graphs like this. If you want to show that it's been warming, find an old photograph. This is the Mendenhall Glacier in the 19th century, and show people how things have changed. This, when I show this, I often get gasps in the audience. It's a visceral change. You know, you never get a visceral response to a line graph. I've tried, it just doesn't work. Talk about the people who are doing it. You know, I think we're trained out of the idea that science is being done by individuals when we write our papers and things, you know, and we kind of go with that thing. But it's really important when you're doing public communication to bring home the humanity. Why is this person doing this thing in this very beautiful place? What is she doing? Why is she doing it? That looks odd. She's counting mosses, and seeing how the different moss species are changing as a function of warming. But it's a great photo as well. Why can't I have this job? I want that job. People identify with people. And when you tell people that they do interesting things and they're looking at interesting things, people are interested because people are doing it. Don't write out the people from your communications. One of the most important techniques, though, is to understand that not everybody has the time or the effort or the inclination to dive into everything that you want to say right now. You have to layer information. If you go skiing, you have some ski results here, right? But if you go skiing, right, there's often a whole bunch of choices. There's the green run that's very gentle and not very challenging. There's the double black diamond run, which is insane. And even if you're capable of doing the double black diamond run, you sometimes start off with the green run just to kind of get your feet, or because you're tired and you really don't need to kill yourself, like, again. It's a function of the person and the time and the inclination. If we provide layered information that allows people to take the bunny slope if they want, or to really dive into the nitty-gritty of all the data and stuff, then they can do that as well. But you have to provide a way to scaffold that information so that they can go from the green to the double black diamond without too much trouble. Communication, of course, can go terribly wrong. Okay, so I'll give you some examples. Anybody remember this? Kepler, 2006. Methane from plants. Remember that? Anybody? Yeah, okay, well, a couple of people. Good, good. So this is a disaster. Okay, so it's an odd result, right? Methane actually coming from leaves, which are designed to provide oxygen to the active centers in the thing, and methane being an anaerobic reaction, that's odd. That's an odd result, which is why it was in Nature. In the press release they put out, they talked all like how methane was the second most important greenhouse gas, and anthropogenic this and anthropogenic that, and they claimed that in fact most of the methane in the atmosphere was in fact of biogenic origin. It's kind of confusing. And then the week before this came out, the big discussion had been whether reforestation should get credits under the Kyoto Protocol, right? So it was all about trees and the Kyoto Protocol and climate change. So, what happened? Do trees share blame for global warming? Global warming, blame the forests. Go snub a tree. Okay, disaster. Even The Guardian, The Guardian is normally pretty good, but this was pretty appalling. They put out a second press release saying, no, that was all a misconception. Like we didn't really mean that. No, this is a natural source. Anyway, and of course, actually only The Guardian made a correction, but nobody else did. Total disaster. Sum total of improved scientific literacy, negative. Plus, 2 years later, all these papers come out saying that this can't be a replicated result, and in fact it's due to contamination of their samples by microbes on the leaves, and nothing to do with the leaves at all. So, lest you think that I am just here to criticize other people, let me put myself out here. In 2014, the temperature record that we curate at NASA indicated that 2014 was going to be a record year. It wasn't a record year by very much, and so given that there's some uncertainty in any one estimate of a year, what we did was did a little calculation that said, well, how likely is it that this really was a record year given the uncertainty in the measurements that we're making? And we did a press conference and the things, and there was this table in there, probability of the warmest year. And we estimated that the likelihood that 2014 was actually the warmest year was about 38%, more than any other year. But, there's some uncertainty there. That was the headline that was in our press release. NASA NOAA find 2014 to be the warmest year in the instrumental record. The Daily Mail took a different view. NASA. We said 2014 was the warmest year on record, but we're only 38% sure that we're right. They took a photograph of me. Well, no, they found a photograph of me, and they put my crime in the caption. Gavin Schmidt of NASA's Goddard Institute for Space Studies admits there's a margin of error. Tell you, like, it's a tough audience out there. Communication is an ethical issue. It really is. We have an ethical responsibility to report the results that are paid for by taxpayers to the general public. Maybe not everybody individually, but collectively we do. We have an ethical issue to ensure the work we do is not abused or misinterpreted. It's our job to do that. And this is a value statement. If you think that living in an informed democracy is something that you support, and you have information that the broader public does not, you owe it to your values to help ensure that the public is indeed informed. Sherwood-Rowland did this very well. So Sherwood-Rowland, as you all know, won the Nobel Prize for chemistry in, I'm not quite sure when he won it, but anyway, it was for work that he did in the 1970s on the depletion of ozone. Many years later, he said this, and he was asked, why did he become such an advocate for change? He said, well, what's the use of having developed a science well enough to make predictions if, in the end, all we're willing to do is stand around and wait for them to come true? And that encompasses our dilemma as well. We make predictions for what the hottest year is going to be. We make predictions for what the trend is going to be, for what the changes in rainfall are going to be, for what the changes in sea level are going to be. And we have to wear these two hats. Our first hat is as a scientist. And we say, oh, look, we made a successful prediction. We studied the universe and we wrestled information out of that and we used it to encapsulate it into a theory and we made a prediction and the prediction worked out. Yay, us! We are so intelligent. And then you're wearing a hat as a citizen which says, I don't want to be right. I don't want it to be the warmest year every year. I don't want the sea level to rise. And so we're making predictions that conflict with our values. And we have to acknowledge that. And when we do acknowledge that, people understand that we are human, we're not automata, and we become more authentic. We are perceived as being more authentic. And there's nothing that communicates better with people than authenticity. I think it was Groucho Marx that said, sincerity is key. If you can fake that, you've got it made. Don't fake it, do it real. As I said before, silence is an option. To avoid criticism, say nothing, do nothing, be nothing. But it's not the only option. It can be terrifying if you're the only head popping up above the parapet and people are using you as target practice. Troll farms in Russia, bloggers in Canada, columnists in the Australian. But it becomes much harder to do if you're not the only one. And it becomes very hard to do if we're all doing it. And we have a lot of work to do. Thank you very much.
Thanks very much, Gavin. That was fantastic. Do we have any questions for Gavin? Some microphones are coming around, so we'll start here with Angela, please.
Oh, stab there.
And if you could just say your name and your institution, please.
Angela Maharaj, Vice President of the Australian Meteorological and Oceanographic Society. Thank you so much, Gavin. That was wonderful. My question is around managing expectations for scientists. We used to be told publish or perish. Then it was collaborate or perish, but you still had to publish as well. Now it's communicate or perish, but you still got to be collaborating and publishing. To my mind, that's a lot of perishing. And I think, do you have any advice as to how scientists within our institutions and our societies like AMOS can come up with a framework where we can allow this to happen in a way that can still let scientists be functional in their workplace and not overburden them?
So, I mean, that's a great question. There's two real responses. One is science is not just sitting in a lab and writing papers. It isn't. It's about coming to conferences like this. It's about communicating your results, not just to our colleagues, but more widely. I mean, that's part of what we do. There's no point in doing our science if nobody ever finds out about it. That doesn't mean that everybody has to spend all day blogging or on Twitter or and some people are much better at this than others. And so, in our lab, I've got about 130 people who nominally work for me. I'd say maybe a dozen are effective communicators, and of those, maybe 6 actually do it well and with enthusiasm. Right? So it's not every single person in the institution that has to be doing this, but it has to be something that's encouraged. And the people that want to do better and have that enthusiasm should be helped to do better. And AMOS can help people to do that. Right? You can run workshops. You can have conversations like this at the meetings. You can help and institutionalize that. It doesn't need to be everybody, but it needs to be more people than it is.
Hi, Gavin. I'm Lyndon Ashcroft from the Bureau of Meteorology and the owner of that drink bottle that rolled down before. Sorry about that.
No worries.
My question is about knowing when to stop. You mentioned that silence is not ideal, and you say that listening is great. But at what stage can you say, this person on Twitter is never going to accept this? Right. This columnist this is their life just as much as science is my life. How do you know when to stop? Okay, so what is your aim? If your aim is to persuade the unpersuadable, you're mostly wasting your time. However, a lot of these conversations are in public, right? If you're having a conversation with a columnist in The Australian, right? You're not the only person reading this, right? The aim there is not to persuade him to change his mind. It's not going to happen, right? The aim is to persuade anybody that's reading that he's a loon and you're very sensible, right? So who are you talking to? Who is your audience, right? And so your goal there should be to project to the real audience, right? The people who are listening or paying attention or clicking, and to talk to them, right? You're not talking to the person you're nominally arguing with. And so when you're doing like somebody comes up to me after a talk and they just want to have a one-to-one conversation about some weird theory that they have about the Smithsonian and the conspiracies and the ship that they found buried in the ice. It's like totally crazy stuff. There's no point in having that conversation. He's not going to be persuaded. I'm not interested. Nobody else is listening. Find the venues, find the mechanisms by which your arguments can reach the largest number of people. And sometimes that is piggybacking on a controversy or a controversial person with a louder microphone than you, because, other people will see it.
Thank you very much. Gavin, have any of your views regarding communication of climate change changed since Donald Trump came to power, or has it strengthened them?
No. So my views have changed over the years. Right, I mean, a decade ago, I wrote an article about how there was this huge difference between scientists and advocates, and now I look at that and I'm going, oh no, that's really naive. The difference that I was perceiving then, and if I was going to write that again now, I would write it again now, is the difference between responsible and irresponsible advocacy. Responsible advocacy, you're explicit about your values, you're telling people how it comes from the science, but you understand that it's a normative thing. Irresponsible advocacy is when all those things are hidden, that you're not really explicit about your values, that you're pretending that the science tells us what to do without including any kind of normative statement, that you're actually working to an agenda that is totally hidden from the people listening, right? So that's the difference I would now think, but that's evolved over time.
Thank you again, and join me now in thanking Gavin for a great talk.
Thank you.